Number 2 on exam 2 review, and it's given a function f of x equals x squared plus 3 over the quantity x minus 1. Find the following. If none, say so. So if you're given a blank, here, make sure you answer it. We want to find the open intervals where f is increasing. Oops, I'm just going to sketch that in. Sorry. And open intervals where f is decreasing, relative maximum points, or relative minimum points and relative maximum points. So we want to find where f is increasing and decreasing. We need to find f prime and set it equal to 0 and where it's undefined, and then put those numbers on a line graph and test for intervals of positive and negative for f prime, and that will tell us the intervals of increasing and decreasing and relative max and min points. So this is a rational function, so we're going to have to use the quotient rule in order to find its derivative. So it's going to be the bottom function times the derivative of the top function, which is 2x, minus the top function minus the derivative of the bottom. The derivative of the bottom function is 1 all over the bottom function squared. So let's clean this up a little bit, makes it easier. So we get 2x squared minus 2x, first part of the numerator, minus x squared minus 3, the second part of the numerator, distributing that negative 1, and it's all over x minus 1 squared. And then that 2x squared minus x squared is just x squared minus 2x minus, oops, writing off the little thing, minus 3 all over x minus 1 squared. And I'm going to factor that, and I should really put in f prime of x there. So finally, f prime of x in fully factored form in the numerator equals x plus 1 times x minus 3, x is x squared. Yep. Just trying to get this down as quick as possible. So the denominator is still this. So now we need to know, where is f prime of x equal to 0? Well, that's where the numerator is equal to 0. So that implies that x equals negative 1 and x equals positive 3. And now we need to know, where is f prime of x? Sorry, f prime of x does not exist, and that implies that x equals positive 1? Yep, because when x equals 1, the denominator equals 0. So now, draw ourselves a little number line graph. We put where f prime is equal to 0 and where it's undefined. We break it up with intervals, so we have f prime is equal to 0 at x equals negative 1, x equals 1, and finally x equals 3, and there's a little arrow heads on there, although I don't know, it's kind of a little obnoxious for me to draw that in, but it's probably helpful, so I'm going to leave it. So now I'll just label those. We have negative 1, and that's where f prime equals 0. I just like to make these little notes down here so I know what's happening there. F prime, and then we have 1, and that's where f prime does not exist, but it's also, and f does not exist, because notice in the original function up here, x equals 1 makes the original function undefined. Therefore, regardless of what these intervals are doing on f, it cannot be a relative max or a min, because a relative max or a min, the original function has to be defined. That's why I make this little notation down here. So finally we have 3, and that's where f prime equals 0. And negative 1 and 3 don't make the original function undefined, so if we get a change of increasing, decreasing on those, they are fair game for relative max and mins. So I'll do the sine of f prime from negative infinity to negative 1. F prime is, let's see, we get a negative times a negative in the numerator, which is a positive, over a positive number, which is a positive, because remember that denominator is always going to be positive no matter what the value is because of the squared. From negative 1 to 1, Let's just try 0. We get a positive times a negative number in the numerator, so that's a negative number in the numerator over a positive number in the denominator, so that's a negative overall value. Between 1 and 3, let's try 2. We get a positive number times a negative number, so we get a negative number in the numerator over the positive number in the denominator. Excuse me, we get a negative number overall. And then finally, to the right of 3, we get a positive times a positive is a positive over a positive is a positive. So now we'll talk about what is happening to f. Well, if f prime is positive, f is increasing. If f prime is negative, f is decreasing. It's still negative, so it's still decreasing. It's kind of a funny little arrow, but anyway. F prime is positive, so f is increasing. So now we can go to listing our intervals. Where is f decreasing? Looks like to me from -1 to 1. Can't include where it doesn't exist because the function doesn't exist there, so don't include that in your interval. So we have -1 to 1 and 1 to 3, it appears to me, and where it's, oh, I'm sorry. Well, you know what? That's pretty sweet. That was where it's decreasing, not where it was increasing. But look at that. Ooh, isn't that slick? Do you wish you could do that on your own paper? I do. Oh, many times. So that's the intervals where it was decreasing. So I looked down here and that's where it's decreasing. So now I need intervals where it was increasing. Well, that was -infinity to -1 and 3 to +infinity. Relative minimum point or points, well, that's where it's going to go from decreasing to increasing. There's only one point where it does that, and that's going to be 3, and that'll be f of 3. You can evaluate the function at 3 and get that y value. So what would it be? It's easy enough. Kind of in a rush here, but I'm going to go ahead and do it. So 3 squared is 9 plus 3 is 12 over 3 minus 1 is 2, so 12 over 2 is 6. The point 36 is a relative min, and that's where the function goes from decreasing to increasing, and the function's defined. Relative maximums, where it's going to go from increasing to decreasing, that's when x is equal to -1, so -1 f of -1, and we'll go ahead and evaluate that one too. -1 squared is 1, 1 plus 3 is 4, 4 over -1 minus 1 is -2, so 4 over -2 is -2. So that's, sorry it's kind of jumbled, but I think you can figure that out. So that's it.